Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Syed Muhamad Idham in Aluwi, metro number 2011497. So now I will be presenting for our group, which is for the subject of Mathematics for Computing 2, section 1, which is group 1. So first of all, the summarization of our group is we chose the topic of the parametric equations. So basically, the parametric equations is actually an equation that is a group of quantities as functions of one or more independent variables called parameters. So by combining these parameters, we can either generate some shape or object. By generating this object, we can also calculate the velocity, which is also known as the parametric curve based on the curve. And so why we chose this topic? Because first of all, it is difficult for an architect or designer to use the same parametric equations over again and again in generating shape in building something. Also, drawing the curves manually could be a hassle because of the value of t, which is time, need to be consistently substituted into the equation multiple times. Secondly, in tracking of a moving object such as airplanes for its movement, location and speed, at each coordinate point will be time consuming as well as calculating its velocity, vertical velocity and overall speed. Thus, we can excel in calculating the velocity, vertical velocity and the overall speed as well as the movement, location and speed by using certain program such as using the Microsoft Excel and coding using a programming language C++. So our group used the Microsoft Excel to plot all of the coordinate points of the parametric equation, and in the same time we can also draw the graph. And for coding, we use the integrated development environment, which is the Dev C++.
Assalamualaikum and hi, my name is Faris Farhan and I will be talking about one of the applications for parametric equations, which is velocity. So say the position of an object at time t is given by the parametric equations here. X equals to t, y equals to 5t squared minus 10t. So how do we find the speed at any given time? So let's say t equals to 2. So how do we find the speed? So we take the horizontal we find the horizontal velocity by finding the derivative and we substitute 2. We also find the vertical velocity by using the function y, and we find the derivative, then we substitute 2. So how do we find the speed at t equals to 2? We just use this formula. We just take the horizontal velocity, we square it, plus the vertical velocity, then we square it. Then we take the value, then we square root it, then we find 10.04. So how do we find velocity in code? So we have the function here, find velocity, and we have equation 1, equation 2, and time t as parameters that we take in. So equation 1 is the for x function and equation 2 is for y function. And what we do is we use the velocity formula before that we've seen before, and we use the, as you can see, we use the function value here. So what is value? So we want to find the value of horizontal velocity and also value of vertical velocity. So what happens in value? It takes in the formula as a string and it takes the t value. So answer is initialized to 0. Now we create a string called polyterm and we scan through the string and we find what's the polynomial. So in the code here it says if polyterm is equals to plus, we just continue. Else we answer equals to answer plus power rule. So what's power rule? So power rule is we're trying to find the derivative and it's a function above here, and we give the power rule the polyterm that we have right now and we give its value. So what happens in power rule, basically we initialize coefficient string here and we try to find the coefficient of every term. So as we can see here, t, every time we find a t, we take the values before it. So this is what happens here. And because it's a string, we want to convert it back to long integer. We use the function et al. And we initialize power string because we want to find the power of any term. We use I equals to I plus 2 because, for example, t is here, is to the power of 2. So if t is at 0, then we plus 2, we find the 2 here. And that's the power of the term. and we take the power, we push it back to power string. And since it's a string, we convert it back to long integer. Then we use the power rules formula, coefficient times power times value to the power minus 1. And this is returned back here into the value function so that it can be added up to the final answer. So we can find the horizontal velocity, and it returns back here into this formula, and it does the same thing for the vertical velocity. Then we square root all of it. That's how we find velocity. Thank you.
My name is Muhamad Haneef, and I will be presenting about the code and description for the parametric curves part of our group project. We have 3 different curves. The first is the involute of a circle, the second is the epicycloid, and the third is the asteroid. For the involute of a circle, this is the part in the code where the function to calculate the x and y coordinates of the circle is called. This is where the function is called. The 2 green circles represent where the function is called, and here we can see that the t, it increases from 0 until 53 by 1. These are the functions that were called from the slide just now. The top is to calculate the x coordinate of the circle. It calculates the value of x according to the formula x equals to a cos t plus t sin t. And the bottom, it calculates the y coordinate for the circle. It calculates the value of y according to the formula y equals to a sin t minus t cos t. The next is the epicycloid. In the code, the epicycloid function is called for calculation. For the epicycloid, the t increases from 1 to 54, incrementing by 1 each time. These are the functions that were called to calculate the x and y coordinates. The top is to calculate the x coordinate of the epicycloid. It calculates the value of x according to the formula x equals to a plus b times cos t and minus b times cos a divided by b plus 1 times t. The bottom is the y coordinate calculating function. It calculates the value of y according to the formula y equals to a plus b times sin t minus b sin a divided by b plus 1 times t. And in this part, the a is equal to 14 and b is equals to 17. So the next one is for the asteroid. So this is the parts in the code where the function for calculating the asteroid coordinates are called. Based on this, you can see that the t is increasing from 2 until 55 by increments of 1. This next slide shows the functions that were called in the code before. The function of calculating the x and y coordinate of the asteroid. The top is to calculate the value of x according to the formula x equals to a cos power 3 t, and the bottom is to calculate the y coordinate of the asteroid. It calculates the value of the y according to the formula y equals to a sin power 3 t. In this part, the a is equals to 10, and after calculating all the values, coordinates, and it outputs the values to math.csv.csv. Once you open the file in Microsoft Excel, you can use the scatter plot with smooth lines function inside Microsoft Excel. you can use it to plot the graph, and with this function with this feature in Microsoft Excel, we can get similar graphs to the graphs which will be also presented in the results section. So that is it from me.
Assalamualaikum warahmatullahi wabarakatuh. My name is Khairul bin Noormaizan, and today I'm gonna present to you the result after we execute the code. So as you can see, this is a result for all equation in the spreadsheet, and as we all know, after we execute the code, the result will be sent to math.csv file. So as you can see here now, we have all the data for the first part of our coding and for the second part of our coding, which is the x time y time velocity, or x time y coordinate for curve 1, curve 2 and curve 3. So now let's take a look on velocity part. I took y point or y coordinate with velocity and plot it against time, and then we get this graph. To make it easier to analyze, I take first 3 points only, and we're gonna analyze it from here. So you can see here, velocity are decreasing for the first second and then start increasing for the rest of the time, and as well as y point, but the y point here, they increasing exponentially. And then we do the same to curve 1, which is we plotting x coordinate and y coordinate into the graph, and then we get these spiral shapes that turn clockwise away from 0, and that's for involute of circle parts. And then we move to epsilon part, which is the curve 2 that we put name in our coding. After we plotting x and y coordinate, we get these shapes. And also same to curve 3, which is asteroid. We plot x and y, and then we got this shape. So for the conclusion of the result, I believe that we found different shapes, or different equation give us different shapes of curve to us to make a new design.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhamad Alif Izzummy bin Muhamad Radhi, and I will continue the presentation with the Sejahtera Academic Framework. So first of all, the Sejahtera Academic Framework in action mention about the guidance principle, and we are linked to the two of them, which is the flexibility and the innovation. So the flexibility that are given to us make us stress-free and also produce the best outcome that we could done, because the time given for us to complete our project, and then the topic is free for us to choose from any topic. And plus, with this flexibility also we come with new idea, which is the innovation. Our project is based on a real life issue where the architects may have some troubles working on making curve with the exact measurement. So our project provide them to make curve by inserting the parametric equation into the coding, and it will make them easier to draw curve or designing a building with many curves. Moving on to the sustainable development goals. So for our project, we focus on the goal number 9 from the Sustainable Development Goals, which is to build a resilient infrastructure, promote sustainable industrialization and foster innovation. Our project can help the architecture to design curve with the parametric equation with more accurate measurements and flawlessly. So this also will contribute to build more sustainable building with an environment-friendly design. By that, the architecture will have more space and time to think and design a reasonable and appropriate building to the environment rather than prioritizing popularity. And then the architects also no need to worry more about designing a building with curve, because they can done it automatically with our coding without do it manually. So that's all from our code. Thank you.